Welcome to the Deep Dive. Today, you and I are taking a fascinating look, really inside the future of flight. We're focusing on aerospace composite ducting.
Right. It might sound a bit niche, maybe, but trust us, this technology humming away sort of behind the scenes in our planes, it's absolutely pivotal.
Exactly. And we've actually got some really interesting findings here. This is from a brand new report by Cognitive Market Research.
Yeah. Hot off the press, April 2025. It's called Aerospace Composite Ducting Market Trends and Future Opportunities.
So think of this, as our quick guide, our deep dive into why this, well, seemingly small component has such huge implications.
For how planes are built, yeah. And really how we'll be flying in the coming years.
So our goal here is really to pull out the core insights without getting totally bogged down in the super technical stuff.
We want to hit the big questions. What's making composite ducting so important now? What's driving its rapid growth?
And what are the really cool innovations happening? Who are the key players? That kind of thing.
Okay, so let's maybe start with the basics. What is aerospace composite ducting?
Good question.
Essentially, you're looking at the aircraft's internal network, like tubes and channels, but instead of traditional metals.
They're made from these advanced composite materials, right?
Right,
Like carbon fiber, maybe fiberglass, mixed with strong polymers.
exactly. And these ducts, they're kind of the unsung heroes. They do everything from pumping air for the cabin's air conditioning and ventilation
Hmm.
to even carrying fuel, which sounds pretty critical.
Oh, absolutely.
And the real game changer, I suppose, is that these composite materials, they just offer serious advantages over the old metal ducting.
That's the key takeaway.
Yeah.
We're talking a much, much better strength-to-weight ratio.
Right, like think super strong but incredibly light, like a carbon fiber bike frame versus an old steel one, sort of.
That's a great analogy. Plus, they handle extreme conditions much better.
Okay.
The report really emphasizes this better resistance to corrosion, which is always a fight in aviation.
A big reduction in weight, which, as we'll see, has this huge ripple effect.
Right.
And just much more flexibility in design. And that freedom is getting more and more important for these sleek, efficient new aircraft.
Okay, so to really underline why this is, a big deal, the market itself, it was valued around, what, $1.5 billion in 2024?
That's right, USD 1,524.8 million, roughly.
And it's projected to jump to nearly $2.2 billion by 2032.
USD 2,168.4 million, yeah. Growing at a compound annual growth rate of 4.5%.
Wow. That kind of growth, that's not just a blip, is it? It really signals a fundamental shift.
Absolutely not. It's significant. And so throughout our discussion today, we'll be tackling, the key questions behind that growth.
Like, what's really fueling it? What are the exciting tech leaps coming? Who's leading the pack?
And also, what challenges does the industry still need to sort of navigate?
Okay, so with that overview, let's really dig into those drivers. What's pushing this market forward?
All right. First big piece, as the report makes really clear, it's the increasing demand for aircraft that are both lightweight and super fuel efficient. That's the primary engine here.
It's a fantastic double whammy, isn't it? Less weight means less fuel burn.
Exactly. Which directly cuts operating costs for airlines. That's huge for them.
And the report actually quantifies that, doesn't it? Saving weight saves fuel big time over the life of a plane.
It really does. We're talking millions in savings potentially and a big cut in the carbon footprint.
Which connects to that other point you mentioned, the pressure on manufacturers to meet stricter environmental rules.
Absolutely. Reducing emissions is, well, it's paramount now. And lighter aircraft, thanks in large part to things like composite ducting, are just key to hitting those targets.
And it's not just swapping out parts, is it? It's about how planes are designed now, the material science.
Precisely. Advances in aerostructure design and the materials themselves are enabling these much more efficient and actually more cost-effective systems overall.
The report even mentioned Boeing and Airbus, right? Launching new models back in 2023 that specifically used composite ducting for fuel savings.
Yes, that's a great real-world example. When the giants adopt it, you know it's important. It really underscores the trend.
Definitely. And beyond the tech, there's just the simple fact that more people are flying.
Right. Global air travel continues its upward climb. More flights, more destinations. That means more demand for new planes.
And naturally, more demand for all the components inside them, including this advanced ducting.
Exactly.
And what about the passenger side? Airlines are always talking about comfort and experience. Does this play a role there too?
It can, yes. Lighter components contribute to better overall aerodynamic performance.
Okay.
And the design flexibility we talked about, that allows engineers to optimize how the ducts are routed, their shape.
Which could mean better airflow in the cabin, more stable temperatures.
Potentially, yes, leading to, enhanced passenger comfort. It all connects.
And this isn't happening in Alcylation, right? The report mentioned a broader trend of using composites in aircraft interiors generally.
That's a good point. Seats, panels, galleys, it all ties back to that relentless push for weight reduction and better performance across the board.
Okay, makes sense. So we've got the drivers down. What about the key trends shaping how this market is actually developing right now?
Well, what's really fascinating is how composite ducting is being integrated much earlier now, right? From the initial design phase of these next-gen aircraft.
So it's not an afterthought anymore.
No, exactly. It's fundamental for hitting those goals of fuel efficiency, passenger comfort, and environmental sustainability.
And the manufacturing itself is evolving. The report mentioned some advanced techniques.
Yeah, things like autoclave processing, curing parts under high pressure and temperature, but also, and this is really interesting, the growing use of additive manufacturing.
3D printing bits.
Exactly. 3D printing is becoming increasingly important. The report highlights how it lets you create these incredibly complex, optimized shapes.
Stuff that was hard or maybe impossible before.
Pretty much. And it cuts down on material waste, which is good for costs and the environment. It can lower production costs overall and, crucially, speed up lead times.
Faster production. Any specific examples?
The report actually name-checks Arrowhead Products as a company really pushing the envelope with using additive manufacturing.
Okay, Arrowhead.
Yeah.
Good to know. And what are the environmental angle on the materials themselves? Recyclability.
Yes, that's becoming a huge focus. There's a definite trend towards developing and using recyclable composite materials.
Like thermoplastics.
Thermoplastic composites, in particular, are getting a lot of attention. With environmental regulations getting tighter, being able to recycle these materials efficiently at the end of their life is a major factor now.
No, the whole life cycle matters. Okay, let's shift gears a bit. Geographically, where's all this action concentrated?
Well, the report shows North America was really the dominant player in 2024, holding nearly 40% of the market share.
Wow, almost half. Why so dominant?
It makes sense when you think about it. You've got the major aerospace manufacturers there, a really strong supply chain, skilled labor.
Boeing, Lockheed, etc.
Right. Plus, significant defense and commercial aircraft production. And the tech infrastructure to support developing these advanced materials.
Okay. And Europe. Not far behind, I gather.
Around 30% market share. Countries like France, Germany, the UK, they're key aerospace hubs.
Airbus territory.
Exactly. And they have a very strong ongoing focus on cutting their carbon footprint. So that drives adoption of lighter composites.
Makes sense. And looking ahead, where's the big growth expected?
Asia Pacific. The report points to really significant growth there, especially in China and India.
Why them specifically?
It's largely down to their rapidly expanding air travel markets. Think about the sheer number of new airports, new routes.
Right, huge demand.
Huge demand, plus their own growing domestic aircraft manufacturing capabilities. Every new plane order there fuels demand for these advanced components.
Okay, massive potential there. Any other regions to watch?
The Middle East and Africa are also seeing rising demand. They're building up their aviation infrastructure and looking for more advanced, efficient aircraft. So it's really becoming a global shift.
It sounds like it. So who are the actual companies making waves in this space? It sounds competitive.
Oh, very competitive. The report highlights that.
And it gives us some names and numbers for 2024.
It does. Senior Plc, based in the UK, comes out as the leader with about 7.5% of the market.
Okay, Senior Plc.
Then you have AIM Aerospace in the US with around 5.6%. And Arrowhead Products, also US-based, with about 4.84%.
So those are the top three, roughly. What makes them stand out? What are their strengths?
Well, Senior Plc, for instance, has extensive experience. They're known for handling really complex ducting solutions.
Right.
And they innovate a lot in high temperature and fire-resistant composites. That makes them a preferred supplier for many big manufacturers.
That specialization must be key. What about AIM Aerospace?
AIM's focus, according to the report, is more on advanced thermoplastic composites. Ah, the recyclable ones we mentioned.
Well, yes, often,
Yeah.
but also materials known for enhanced durability and flexibility, crucial for certain demanding spots on an aircraft.
Okay. And Arrowhead Products. We mentioned their 3D printing.
Right. Their expertise lies in custom-engineered solutions. They serve both military and commercial clients.
So specialized stuff.
Yeah, things like environmental control systems for the cabin or cooling for sensitive avionics equipment, highly specialized ducting.
So it's clear these leaders aren't just, sitting still. They're investing heavily in R&D.
Constantly. The report really underscores that. They're pushing to meet these ever-evolving demands.
Lighter weight, better heat resistance, improved aerodynamics.
Exactly. It all aligns with that big industry push for more sustainable aviation.
Okay, let's dive a bit deeper into the materials themselves. You mentioned carbon fiber reinforced composites and thermoplastic polymers. What makes them so good for this?
Well, as we touched on, it fundamentally boils down to that superior strength-to-weight ratio.
Right. Strong but light. Incredibly strong, structurally sound, but significantly lighter than the metals they replace.
And it's more than just weight, isn't it? Durability, handling tough conditions.
Absolutely crucial. These advanced composites offer much better resistance to extreme temperature swings, moisture, corrosion, all big factors in that harsh aerospace environment.
Things metals might struggle more with.
Potentially, yeah. Composites often handle fatigue better, too. And the report specifically mentions Senior Plc and AIM Aerospace as leaders in using these advanced materials.
Okay. And there was another specific material development mentioned involving Eaton. Sounded quite interesting.
Yes, that's potentially quite transformative. Eaton is working hard to replace aluminum, which has been, a bedrock material for decades, with something called carbon-reinforced PEKK.
PKK, polyether catenated cone, that's a mouthful.
It is. But the key thing is what it offers. Carbon-reinforced PEKK seems to provide this great combination of superior strength, even better durability than some other composites, and really excellent resistance to very high temperatures.
Wow. So for air ducts specifically, this could be a real game changer.
That's the potential, yes.
So this isn't just tweaking things slightly. It could genuinely revolutionize performance, safety, even sustainability.
That's precisely the implication. If you can swap out heavier aluminum for lighter, more durable PKK in these systems, you could see significant gains across the board in aircraft design and operation.
Okay, so we've covered drivers, trends, players, materials. Let's talk opportunities.
Right.
Where are the big openings in this market going forward?
Well, the ongoing advances in materials, science, and design engineering themselves are just constantly creating new opportunities.
Right. Better materials, better ways to use them.
Exactly. And as we keep saying, that crucial role composite ducting plays in reducing overall aircraft weight. That's a massive driver.
Yeah.
Better fuel efficiency, better performance.
And it's not just weight. The inherent properties, heat resistance, corrosion resistance, fatigue life being better than aluminum, opens up new design possibilities, doesn't it?
It absolutely does. Broader applications, potentially more optimized systems.
And connecting back to the big picture, the industry needing to cut carbon footprints and operating costs.
The demand for high-performance composite ducting just keeps growing. It's a direct solution to those pressures.
Plus more people flying, especially in those emerging economies we talked about.
Means a growing need for modern, efficient planes packed with these advanced components.
And the fact that the next generation of aircraft are being designed with sustainability and efficiency as top priorities.
That just fuels more investment and faster innovation in lightweight materials like composites.
And seeing Boeing and Airbus actively using these composites in their latest planes, that's a huge validation, right? Signals real market expansion.
Definitely. It shows it's moving from niche to mainstream essential technology.
Okay, so loads of opportunity. But it can't all be smooth sailing. What about the challenges? The report mentioned some hurdles.
Yes, absolutely. There are significant challenges the industry still needs to tackle. One big one is the initial manufacturing cost.
Right. These advanced composites, CFRP and others, they're just more expensive to make than traditional metals.
Generally, yes. Producing them is complex, often energy intensive. And the specialized manufacturing techniques needed to meet strict aerospace quality and safety standards add further cost.
So that higher upfront cost could be a barrier, maybe for smaller plane makers or those on tighter budgets.
It certainly can limit adoption, especially in more cost-sensitive parts of the market. It's a constraint.
Okay, what else? The certification process came up. Sounds complex.
It is. And necessarily so, right? Safety is paramount. All aerospace parts need rigorous testing to meet standards from authorities like the FAA in the US or EASA in Europe.
And for new composite materials, it's even tougher.
It can be, because their properties are different from metals. Proving their long-term performance and safety under all conditions can require extensive, time-consuming, and expensive testing and validation.
Makes sense.
Yeah.
Safety first. What about once the parts are actually on the plane? Maintenance and repair.
That's another area the report touches on. While composites are generally very durable,
Mm-hmm.
when damage does happen, repairing them can often be more complex, maybe more costly than fixing traditional metal parts.
So potentially longer downtime for the aircraft.
Huh.
Higher maintenance bills.
It can be a factor, yes. It might require specialized technicians, specific environmental conditions for the repair. It's not always as straightforward as patching metal.
So it's kind of a trade-off then. Amazing performance and weight savings, but maybe higher initial costs and more complex repairs later.
That's a good way to put it. And it's a trade-off the industry is constantly working on, developing better, faster, cheaper repair techniques and materials.
Okay, well, we have certainly covered a lot of ground here in this
Mhm.
deep dive. Let's try and synthesize this. What are the absolute key takeaways?
I think, in summary, we've seen a market that's clearly experiencing strong, accelerating growth, and it's fundamentally driven by that relentless aerospace pursuit of lighter, more fuel-efficient, and more sustainable aircraft.
Right, that core need is pushing everything else.
Exactly, and that demand is fueling really significant innovation, both in the advanced composite materials themselves, like PK, and in the manufacturing processes, like additive manufacturing.
And we got a sense of who's leading the charge companies like Senior Plc, AM, Arrowhead, and how the market looks different in different parts of the world.
Yes, the key players, the regional dynamics, and those exciting technological leaps, like the potential for carbon-reinforced PK to maybe even replace aluminum in some key areas. That's huge.
But it's crucial to remember the flip side too, right? The challenges.
Absolutely. While the opportunities are massive, the industry still has to wrestle with those higher manufacturing costs for composites and the complexities around certification and long-term maintenance and repair. It's a balance.
So hopefully anyone listening along with us now has a much clearer, much deeper understanding of this really vital and rapidly evolving piece of the aerospace puzzle.
You should definitely feel well informed now about the forces shaping a big part of the future of air travel. And, considering all these advancements we've talked about, especially these potentially revolutionary materials like carbon-reinforced PK, it does make you think, doesn't it?
How so?
Well, looking beyond just air ducts, what other traditional aircraft components do you think are now ripe for a similar lightweight composite revolution?
Ah, interesting question. Like, what else could be made lighter and stronger?
Exactly. And what kind of impact could that have on the future of air travel? Going beyond just fuel efficiency, maybe enabling totally new aircraft designs or capabilities.
That is a fascinating thought to mull over. Where else could composites take us?
Something to consider as the aerospace industry just keeps evolving. Material science is clearly right at the heart of shaping what the future of flight is going to look like.